So polymorphism is most useful to club together common functionality in the base classes. And through polymorphism, we also create interfaces through which the base classes can communicate with the other component. And no matter which other functions come into the various derived classes, at least the base class routines are guaranteed to work as expected. So look at the header file which is shown on the right. We have the same class hierarchy, that is, we have a cnum class, and the cfrac class does a public derivation from the cnum class. We have the same getType function here. Additionally, what we have done is we have actually introduced the getVal function. And we also add the virtual keyword in front of the getVal to demonstrate that this function can be re-implemented in the derived classes. In the class cfrac, we again have the virtual float getVal, and note that the virtual keyword exists in both the places. And it is not necessary for cfrac to re-implement getVal because the base class is going to provide at least one definition of getVal. So let's look at the definitions of these functions. And we have a float cnum : getVal. In this case, what we do is we actually just return the val. However, if someone calls the getVal of cfrac, then what we do is we actually fix the precision. So this is consistent with the example that we had taken just now in the previous slide, that if someone is calling the getVal of cfrac, then he is going to get a precision, and this could be the new modified behavior. Whereas if someone calls the cfrac of the base class, he is always going to get a consistent behavior in which the precision has not been fixed. So this kind of a style also forces us to do what we call as the interface based design, in which the base classes very clearly specify the interface using which the other components of the program need to communicate. And these interfaces our architect is typically going to fix right at the beginning of the project design. In the previous slide, we re-implemented the getVal function. However, the interface was defined in such a way that there was no necessity to re-implement it, because the base class anyway had an implementation of getVal. However, there could be a design style in which we want to force that the particular function must be implemented. So in such cases, what we can do is we can use the pure virtual functions. And pure virtual functions are those which must be implemented by the deriving class before an object can be instantiated. Classes containing pure virtual functions are known as abstract classes. And the abstract classes are again used to define the interfaces. So take a concrete example here. What we have is a operator equal to, and this has been defined as a pure virtual inside cnum. So what we are saying is that no matter what kind of a number you create out of cnum, and that is by deriving this particular class, you must implement at least the equal to operator so that we can use it in the comparison. Now what we do is we compile our same program, and we have not defined this pure virtual function operator which has been written here. The compiler immediately barks and gives us the error. So the error is cannot declare variable temp to be of abstract type cfrac because we wanted to create a temp variable, because the following virtual functions are pure within cfrac, and he has specifically mentioned this particular function.